Subtopic 1.2 Integration of Trigonometric Functions. At the end of this lesson, students should be able to solve the integral of trigo functions sin ax, cos ax, and secant squared ax. Integration of trigonometric functions. Integrate sin ax plus b equal to negative cos ax plus b over a plus c. And over a here is from the derivative of the angle. Next, integrate cos ax plus b equal to sin ax plus b over a plus c. And over a here is from the derivative of the angle. And last one, integrate secant squared ax plus b equal to tangent ax plus b over a plus c. A from the derivative of the angle. Example number 8. A. Integrate sin 3x with respect to x equal to negative cos 3x divided by 3. And 3 is the derivative of the angle. Don't forget to write plus c. Part B. Integrate cos 4 over 5x equal to positive sin 4 over 5x. And we need to divide by the derivative of the angle. So, divide by 4 over 5 plus c. Okay, and the final answer will be 5 over 4 sin 4 over 5 x plus c. And if you notice here, the angle remains the same. We cannot change the angle. Next, part C. Integrate secant squared 3x plus 2 equal to tangent. Okay, the angle remains the same. Tangent 3x plus 2. Then divide by the derivative of the angle. So we will get divide by 3 plus c. Part D. Integrate sin x plus cos 3x. We need to integrate one by one. Integrate sin x is negative cos x. Actually, divide by 1. And 1 is from the derivative of x. Plus, integrate cos 3x is sin 3x divided by 3 plus c. So, final answer is negative cos x plus sin 3x over 3 plus c. E. Integrate cos 4x plus 4 sin 3x plus 5 with respect to x. We need to integrate one by one. Integrate cos 5x is sin 4x over 4 plus, for the constant, integrate sign is negative cos 3x plus 5 over 3 plus c. Final answer will be sin 4x over 4 minus 4 over 3 cos 3x plus 5 plus c. Part F. Integrate 1 over cos squared 2x minus 5 cos 4x. The first term involving the fraction. And we cannot integrate the fraction directly. Therefore, we need to simplify the first term as secant squared 2x and minus 5 cos 4x for the second term. And integrate secant squared is tangent to x. Never ever change the angle. And don't forget to divide by 2 from the derivative of the angle. Minus 5, the constant. Integrate cos 4x is sin 4x over 4 plus c. So the final answer is tangent to x over 2 minus 5 over 4 sin 4x plus c. Subtopic 1.3 Techniques of Integration. At the end of this lesson, students should be able to find the integral by using substitution method. Perform integration by parts and solve the integral of rational function by means of decomposition into partial fractions. The first part is integration by substitution. The substitution method turns an unfamiliar integral into one we can evaluate. In other words, substitution gives us a simpler integral involving the variable u. And here given a few steps to solve the integration by substitution. First, choose a new variable u. We need to choose a suitable variable u. Next, determine the differential dx in terms of u and du. So first, choose u. Second, we need to differentiate. Third, we substitute. And number 4, integrate the resulting integral. For this one must be in terms of u. And the last one, return to the initial variable x. Okay, so we go to the first example. Use suitable substitutions to evaluate the following integrals. First, we have integrate x cubed plus 2x times 3x squared plus 2 dx. For substitution, how to choose u? Okay, macam mana nak pilih U? Usually, U is a function with higher degree or the more complicated function. Okay, so for this case, for part A, we have x cubed plus 2x. Another one is 3x squared plus 2. So, which one is more complicated? Yes, x cubed plus 2x. Got the higher degree, isn't it? So, we choose U equal to x cubed plus 2x. Okay? And if you notice here, the first part, the first term, is a polynomial function, and the second factor here, the second term, is also a polynomial function. Both are from the same family. So usually we will use substitution method. Okay? So the first step is to choose U. Second step, we need to differentiate. Okay? So du dx, for now we are using x as variable. So du dx equal to 3x squared plus 2. Okay? Third step, we need to substitute. All must be in terms of U. Okay? Before that, I want you to rearrange the function so that the function becomes, the integral becomes, the first part will be the function related to U, and the second part will be the other functions, and dx, the last one. Okay, so for this case, our U, okay, is the first function, which is, okay, the first function is related to U already. So we don't have to rearrange the order of the function. So for this case, I will write integrate x cubed plus 2x. Okay, so this is the function related to U. And the next one is 3x squared plus 2 dx. So this is the other functions. Now we will substitute all in terms of U. So this is U. And the next part here is related to your differentiation. And if we rearrange the term here, the derivative, we will get 3x squared plus 2 dx equal to du. Meaning that we have integrate U du. Okay? Next, number 4, step number 4, we need to integrate. We have integrate U du. The answer will be U squared over 2 plus C. And step number 5, we need to substitute back to x. we need to state our final answer in terms of x. Therefore, this is equal to x cubed plus 2x squared divided by 2 plus c. Example part B, 3x squared, a polynomial function sin x cubed is a trigo function. So, sin x cubed is more complicated, isn't it? So, we rewrite as sin x cubed times 3x squared dx. We write the function related to u first. Okay. Dan kalau awak perhatikan dekat sini, dekat belakang ni, okay, we have 3x squared. Okay. Kalau kita ambil u, keseluruhan function u, and if we try to differentiate, we will get cos. Sedangkan function kita dekat belakang ni tiada sebutan cos. So, untuk kes ini, kita akan guna angle of the trigo function as u. So, we use u equals to x cubed. Dan, kalau kita differentiate, du dx equal to 3x squared. Okay? And similar, or for this case, is exactly equal to the remaining function, the function at the back. Okay, so now we rearrange 3x squared dx equal to du, meaning that integration of sin x cubed 3x squared dx can be written as integrate sin u times du. Okay, 3x squared dx is du. And if we integrate, we will get negative cos u plus c, or negative cos x cubed plus c. Settle for part B. For part C, we have exponent 3x for numerator and exponent 3x minus 1 for the denominator. Okay, both are exponential functions. Okay, so yang mana satu yang lagi susah? Yes, both susah, isn't it? But usually we will use the denominator as u. So we take u equal to exponent 3x minus 1. Du dx equal to 3 exponent 3x. Okay, and the integral here can be written as, okay, integrate 1 over exponent 3x minus 1 times exponent 3x dx. Okay, the first part is related to u. Okay, and if we try to compare the remaining function, the function at the back with the derivative, okay, so we can rearrange exponent 3x dx equal to du over 3. Therefore, the function, the integral becomes 1 over u times du over 3. Or 1 over 3 integrate 1 over u du. The answer is 1 over 3 ln u plus c, or 1 over 3 ln exponent 3x minus 1 is our u and plus c. Done for question part C. Next, part D. Ln 2x cubed over x. Which one is more complicated? Yes, the numerator is more complicated. So we can write as ln 2x cubed times 1 over x dx. The first part is related to u. Okay? And for this case, okay, we will use ln 2x as u. Biasanya untuk substitution, we ignore the power. Now will be easier. Okay, so du dx equal to 1 over 2x times 2 equal to 1 over x. And look at your second function, 1 over x and dx. Therefore, we can rearrange the derivative becomes 1 over x dx equal to du. Now we substitute, integrate. Ln 2x cubed is u cubed times 1 over x dx is du equal to u power of 4 over 4 plus c. And as final step, we substitute the term, okay? We substitute the answer in terms of x. Ln 2x power of 4 over 4 plus c. And the last one, part E. Integrate tangent 3x dx can be written as integrate sine 3x over cos 3x dx. Okay, and we will use the denominator as u. U equal to cos 3x. Du dx equal to negative 3 sine 3x. And if I rewrite the function, I will get integrate 1 over cos 3x first. This function is related to u and times sine 3x dx. For the second function, we have sine 3x dx. For the derivative, we have negative 3 sine 3x. And on the left, we have over dx. Now, we will rearrange the derivative first. So, we have sine 3x dx equal to du over negative 3. Next, we substitute into the integral. So 1 over u times sine 3x dx is du over negative 3. Or we can write as negative 1 over 3 integrate 1 over u du. The answer is negative 1 over 3 ln u plus c. The final step is negative 1 over 3 ln, okay, we change u to x. So what is u? U is cos 3x. Then plus c.